Welcome to Black Adam. So we have the electromotive force, we have the voltmeter, resistors, and then we have parallel resistor. So that's parallel, which means the path splits between one resistor and the other. So we have resistor 1, ratio 1 to 2, and then we have electromotive force and the internal resistor, which is 0.2, and then we have voltmeter, switch, and so forth, ammeter, and the resistors. So the first question is that it's twice, so that means resistor 1 to 2 is resistor x to y is 1 to 2. So resistor y is 2 times the resistor of x. Then give a reason why the current won't pass through that. It's because the other path does not have resistance. So it's rather just go freeway than where you have a roadblock. So that's the answer, because other path has no resistance. Okay, so that's it. And then that is it. The electricity goes there, it doesn't go to the RZ. So calculate the resistance of Rx, and then you know that we have to gauge all the total resistance. So we're going to use the electromotive equation. So E is 12 volts, current given is 5.5 ammeter, and then resistor internal, that's 0.2 ohm, and then we have resistor y, we don't know, that's what we have to calculate, and then we know that that's parallel there. So we have Rx and Ry, and the ratio is 1 to 2. And then the equation for electromotive force is current multiplied by bracket external resistor plus internal resistor. Getting a calculator there. 12 is equals to 5.5, and then we have R external resistor plus 0.2 internal resistor, and then simplifying further we have 5.5 R plus 5.5 multiplied by 0.2 gives us 1.1. So we have 1.1 there, which is 1.1. Then 5.5 R is equals to 12 minus 1.1. Then R is going to be 12 minus 1.1 gives us 10.9. So that's going to be 10.9 all divided by 5.5 to give us 10.9 divided by 5.5 gives us 1.98, rounding to 2 decimal places. It's 1.98. And then we say late Rx is equals to x, and then Ry, because it's 2 times, that would be 2 times x. So we have x there, and then we have 2x there. Then we know that resistor total parallel, we're gonna be a product over sum. So that is going to be x times 2x over x plus 2x. So x times 2x is going to give us 2x squared. X plus 2x is 3x. So simplifying further gives us 2x over 3. And then that means that that is equivalent to 1.98 total resistance calculated previously. then 2x is going to be 3 times 1.98. So divide both sides by 2. That gives us x is equivalent to 3 times 1.98 is 5.94. Divide by 2 is 2.97. So 2.97. So our resistor Y is going to be 2 times Rx. 2 times x, that's 2.97 times 2. 2 times 2.97 gives us 5.94. So it's going to be 5.94. And that's our answer for 8.2. And then calculate the power dissipated at Rx. So power, because we have current and then we have Rx, so that will mean that we have current, we don't know, but we know that the ratio is as it splits. Let's check as it splits there. Okay, so that's 5.5 ampere, and then that is Rx, that's Ry, so that is x, and 2x, so that's 1 to 2, that's 100%, so that is going to be, okay, because it's a small part, 1 to 2, so it's going to be 1 to 2. So that means that we have 66.67%, let's make 1, and then we have 33.33% on Ry. Then the current there is going to be, changing that to percent, it's going to be 0, it's going to be 6.67%, okay, that's going to be 6.67 divided by 100, that gives us 0.367, so 0.367 times 5.5 ampere, that will give us 0.366 multiplied by 5.5 is 3.67, so it's going to be 3.67 ampere. So from there, power is, we now have the current, so it's 3.67 squared multiplied by the resistor there. Remember, our resistor there is, resistance in X is 2.97. Okay, from 2.97 then, okay, 0.67 squared multiplied by 2.97, then our power is 40.00, so it's 40 watts. That's the unit for power, that's watts. The next question, calculate the reading on the voltmeter. The reading is IR. Well, let us look at the current as Y, and then the voltmeter is at Y, so current is 1, okay, multiplied by 5.94, so it's 1.3 multiplied by 5.94, that's 1.3, that's what we were given there, 1.3, so that is 7.72 volts. And then that's the voltmeter reading at Ry. And then we have, if it's going to calculate the reading on the ammeter. So the reading on the ammeter there, we have current, we don't know, resistors 2, is resistor Z, we don't know. So remember that when it was open, okay, that one is open, so the current now flows into RZ, goes through up to the ammeter and so forth. So the current there is what we don't know. So we need to find RZ first. So electromotive force is equals to I bracket a resistor Y plus resistor Z plus internal resistor. So that's 12. Current there, which is unknown. Okay, it's 1.8 given. And then resistor, when it's off, resistor 5.94, that's RY, and then Z, that's what we don't know. And then we know that our internal 0.2. And this is 12. That term is that. Okay, that term is that. Okay, 5.94 plus 0.2 give us 6.14. So that is RZ plus 6.14, and then multiplying that we have 1.8 RZ plus 1.3 multiplied by 6.14, 7,982. 7,982. Okay, that's 1.3, and then we have 1.3 R, and then is equals to 12 minus 7.982. So RZ is going to be 12 minus 7.982. That'll give us 4.02 ohm. So that's the resistance for RZ. So with that in mind, what we do, we update our information, and then our information now, resistor total external is going to be that and that. So that is going to be, I'm sure it's going to be 1.98. Yeah, it's going to 1.98 the power plus the 4.02. So that's external resistors now. So adding that together, 1.98 plus 4.02 gives us 6. So 6 ohm. There's an updated total resistance external. So we're going back to electromotive force equation. We substitute 12 volts for the EMF, and then we have current unknown. Okay, so that is 6 plus 0.2. That's 6.02 I. So now current is going to be 12 divided by 6.2. 0.2, yeah, 6.2. So 12 minus 6.2 will give us 1.94 ampere. And that's our final answer. Thank you so much for watching, and don't forget to follow or subscribe. And it's your